All right, so this video we're going to take a slightly different look at what to do with these confidence intervals. So take a moment on your own real quick and just fill in the top part of the sheet in terms of the formulas for confidence intervals for proportions and the conditions, the confidence intervals for means. Just so go ahead and just pause this, fill that in on your own. No, seriously, just pause it, fill it in on your own, and then in just a second, all of a sudden this will magically appear. So just hit the pause button, try to fill in all this information on intervals and conditions on your own to see if you can remember it. So there's all of that information. This is stuff that we've been talking about. So the slightly different variation on this, all of a sudden, let's say that we want to start to create some of these sample sizes or some of these confidence intervals, but we want to be within a certain percentage of the true value. It becomes important all of a sudden that we would need to know what this is called is the margin of error, right? How close do we want to be to the true value? So the margin of error is pretty much, it's going to be that critical value multiplied by the standard error. In other words, it's really just the second part of your interval, what you did with the plus or minus. So it's like that z star times standard deviation, or the t star times standard deviation. So for proportions, the second part of the interval is um, z star times pq over n. For means, again, we're going to stick with z star here, but this time it was, standard deviation over square root of n. So it's essentially, it's the second part of the interval. If p or p hat is unknown in these problems, then what you're going to use is 0.5. So if you think for a moment, how could you obtain a smaller margin of error? So regardless of if you're going to use means or proportions, well, how can we make that value smaller? Well, one of the ways that we can get a smaller margin of error, if you think about this, the thing you're dividing by in both of these is n. So to make that smaller, you could increase sample size. The other way to make a margin of error smaller, well, how did you make your interval smaller? A smaller interval came from, think about it, pause, dramatic pause, smaller interval came from, right, a smaller critical value, right? So in other words, you decrease your confidence level, right? So you think about it, the z star for 95% is a lot smaller than the z star for 99%. So what does this look like? So suppose a candidate is planning on doing a poll and wants to estimate the true voter support within 3% of the true value with 95% confidence. So how big of a sample should they go out and get? So here it is, within 3%. So here's your margin of error right here. Here's our confidence level. And so what we want to do, we want our margin of error, right? Again, so the big idea, the margin of error equals critical value times standard error. Okay, so here we go. This is, you think about support for a candidate, that's a percentage. So we're talking about a proportion problem here. So the margin of error is 0.03. What's the critical value associated with 95%? That should be in the back of our brains, 1.95. And then since this is proportions, we're going to do square root of PQ over N. Well, the N is what we're going to solve for. They don't actually give us an idea of, well, we think that, about 25, 50, 65% of people are in favor of this candidate. We don't know. So in order to be safe, what you're going to use is that 0.5. This is the safest P that you can use to get kind of the widest idea. So now it's just a matter of doing some algebra. So take the 0.03 and we divide both sides by 1.95. All right, so we get 0.015 equals the square root of, I'm just going to go ahead and multiply those together, 0.25 over n. Square both sides. So now you got 0.0024 equals 0.25 over n. And then finally, in order to solve this thing, n goes to one side, so n is going to equal 0.25 over 0.00024. And all I'm really doing, guys, I'm not actually using the numbers here. I just keep using the previous answer in the calculator. So n here is 1056.25. And with these problems, you're always going to go up to the next person. Regardless of what the decimal is, go up. So really, for us, we need, I'll write it over here to the right in blue. We need 1057 people. So always round up. Right? Company claims its program will allow your computer to download movies quickly. To test this, a movie will be downloaded multiple times and the mean download time recorded. It is estimated that the standard deviation of download times is about 10 minutes. So how many trials must we run to be 95% confident our estimate is within a, and then this doesn't have the O, but there's margin of error, that ME. Sometimes you'll see it abbreviated ME. So how many trials must we run to be 95% confident? So again, margin of error equals critical value times standard error, or standard deviation, if you will, once we do all the fun stuff to it. So here we go. This is a means problem, right? Here we go, multiple times the mean download. So this time, margin of error is 8. We want to be 95% confident, so that would be 1.96. And here, the sigma, we're told, is about 10 minutes. So, oh, excuse me, about 10 minutes over the square root of n. Now it's just a matter, let's do some math. So divide both sides by 1.96. 4.08 equals 10 over the square root of n, which means the square root of n equals 10 over 4.08. So 10 over my previous answer, so that's square root of n equals 2.45, square both sides. So n equals 6.0025, which means we need 7 downloads. One more example here. Fox News poll estimates 82% of voters think global warming exists. It has a margin of error of 3%. So suppose an environmental group wants to follow up with a different survey to determine a 95% confidence interval with a smaller margin of error of 2. How big of a sample should they need? So here we go. We don't know how big the original sample was, but here they'd like to make the margin of error smaller. So probably they'd like to do a bigger sample. Well, how big of a sample do they need? So here's our margin of error. That's our new one, 0.02. Here, 82%, that's a P that's being thrown around. So we're talking about a proportion problem. So the margin of error, the critical value, 95% again, 1.96. And then we go, since we have a P given to us, we've got 0.82 over 0.18 over n. So now it's just a matter of doing a little bit of work. 0.02 divided by 1.96, so we have 0.01 equals the square root. I'm just going to go ahead, 0.82 times 0.18 is 0.1476 over n. Square both sides, so 0.01 squared is, allow me, I guess, so 0.0001 equals 0.1476 over n. So n equals 0.1476 over 0.0001. So n here, exactly 1,476 people are needed. So take a second, pause the video, try number 4, and then I'll throw the answer up here in just a second. So pause the video, seriously pause it, try number 4, because the answer is going to pop up in 3, 2. So there's your answer. Now, one of the things to notice, actually all of these sample size problems are going to end up using Z star instead of T star. And if you think about it for just a moment, that's because T star requires you to know a sample size, right? T star is based on degrees of freedom. Degrees of freedom is based on sample size. We don't know sample size, which means all of these problems are going to deal with Z star. So on some levels, these problems don't get too tricky because you're either doing a proportion problem a mean problem, and the mean problems are all Z star, unlike the intervals. So at this point, if you'll either work on your online homework or the Frappies for the remainder of the period, that way you can get a good jump on that stuff. And if you have questions on this stuff, we'll touch base over the next couple days.